If you've ever wondered how Appwrite and Supabase compare head-to-head, there's a really good article out there that does a deep dive into a series of performance tests that's quite revealing. This article goes in depth into all the tests that were run and really does a good job of showing how both Appwrite and Supabase perform under various conditions. This article was posted by the CTO of a company called Codigy, and in the article, Maxime explains that his goal for running these tests was to evaluate the performance, scalability, and ease of use between Appwrite and Supabase. All of the information that I'm going to be referencing here is from this article, so at some point, I highly recommend that you give it a read because the level of detail is quite impressive. Maxime documents his entire thought process, specific details to how the tests are run and their results, and even provides the source code to these tests, so if you want to run them for yourself, you can just go ahead and clone that repo and check them, see if they match up to his results. According to the article, the objective of running these tests was the following. First, see how both Appwrite and Supabase handle an e-commerce simulation over a series of tests, measure the performance of both self-hosted and cloud options, see which platform is better suited for your specific needs based on performance, flexibility, and ease of use, and finally, measure cost-effective scaling by seeing how many users a 5 to 30 euro server can support on self-hosted configurations. To run these tests, projects were created with both Appwrite and Supabase. Each project consisted of a database with two tables, so one for products and one for users, and these were imported with dummy data. 5,000 users and 25,000 products. Now let's get into the details of how these tests were run. First, a series of endpoints were created that make a request to both an Appwrite and Supabase backend. To simulate a typical user interaction, during the test, a virtual user will have to do the following. First, the virtual user will make a request to receive a user from the users table. Then they'll make a request to the products endpoint, where we'll match a set of products by some given values, sort them in ascending order, and then limit them to a specific set of products. So a virtual user is going to be making two requests on each iteration during a test, and this is supposed to represent a typical flow when a user visits a website. They'll see their information, and then a list of products will be rendered out within their dashboard. Now, typically, you're going to have something like client-side caching that would reduce this workload, but because we're trying to stress test a backend server here, we're just going to go ahead and exclude that. The results in this article primarily focus on the outcome of two very important tests. This is a series of load point test and breakpoint test. Now, for those of you that might not be familiar with how performance testing works, I quickly want to summarize this to give you a better understanding of what we're looking at once we start diving into this. So performance testing is a way for us to see how our application would handle various conditions by trying to simulate a real-world environment. And a typical performance test would consist of multiple tests, some of which were mentioned in this article, such as stress testing, spike testing, load testing, and breakpoint tests. So for example, a spike test is where we simulate how our application would handle a sudden increase in traffic. So we're spiking that traffic and we want to see what our application does in this situation. And then we have a stress test where we would simulate how our application handles a steady growth over time. And we want to see what kind of load we can put on it. These simulations allow us to recreate what real network requests would look like through virtual users. The article mentions more tests that were run, but the results focus on two main tests. This is a load test and a series of breakpoint tests, so we're going to focus on these. So a breakpoint test is important because it allows us to check the max capacity of our system before it begins to perform poorly. This is done in a series of stages, and what we do here is we first start hammering our system with a series of network requests, and through these stages, we begin increasing our number of virtual users to the point where we start overwhelming our system. The point at which our application begins to perform poorly is now considered our breakpoint, and from here, we can check how many virtual users and network requests were we able to handle before our application started having issues. The other test results this article highlights is from a load test. Now, a load test simply measures how our application performs over a period of time with a steady number of users. So the goal here is to simply pull in some data points. We want to know how many virtual users can our application handle, how many requests can it take in, and what's the average response time before our application becomes overwhelmed. So we're not trying to break it, we're simply trying to see how far we can push it where it still remains consistent. In this case, for the load test, Maxime set the following requirements for a test to pass. So 99% of the requests had to be complete in under 1,000 milliseconds, 95% had to be completed in under 500 milliseconds, and then 90% had to be returned in under 200, and 99% of the responses had to be returned with the status code of 200 OK. Okay, so now it's time to take a look at the test results and see how Appwrite and Supabase compare head to head. For the self-hosted portion of this, Maxime used Hetzner cloud shared vCPUs. These are affordable cloud machines that you pay for based on minutes usage without a maximum monthly limit. It means that no matter what you do on your server, you won't exceed the limit. And for cloud, the tests were limited to the free tier for both Appwrite and Supabase to simulate the most cost-effective setup. Starting with the self-hosted portion, let's take a look at the 4GB vCPU. For the breakpoint test, Appwrite was a clear winner across all data points. Appwrite was able to handle 2,000 virtual users to Supabase's 1,300, processed more requests, and had a better average response time. This was honestly quite impressive to see. The results on the same instance for the load test were even more staggering. Appwrite was able to sustain 60 virtual users to Supabase's 10 and was able to handle 5 times the capacity for virtual users and network requests handled. When we jump over to the 16GB instance, Appwrite outperformed again by nearly double the virtual users and requests, while also maintaining a better average response time during the breakpoint test. The load test on the 16GB instance had the same pattern, with Appwrite outperforming Supabase's virtual user capacity 250 to 45 and request by 2,900 to Supabase's 4,400. This pattern continued as the test scaled up to the 32GB instance with some slight variations. During the breakpoint test, Appwrite again outperformed by nearly 2 times across all data points, and for the load test, pretty much stayed consistently ahead with some slight variations when measuring the response time in the 99th percentile. Now, things get interesting when we jump into the cloud instances. For these, we only have the results to the load test, which reveal that even on cloud instances, Appwrite still outperformed. The results show that Appwrite Cloud was able to handle 130 virtual users to Supabase's 45 and processed 3 times the amount of requests. Now, the results vary when it comes to the 95 and 99 percentile, with Supabase outperforming in the 99 with a significant margin, but remaining relatively equal in the 90 percentile. Oh, and by the way, quick disclaimer I wanted to add to these test results for the self-hosted instances. It's really difficult to compare these setups one for one due to latency and other factors that come into play, so while these test results are informative, they really should be taken with a grain of salt. When the results for the load test are graphed out together, we get a clear picture of how each platform performed in comparison. And as a reminder, the comfort zone in this case refers to the number of virtual users our server can handle simultaneously while maintaining acceptable performance defined by our thresholds. To quote directly from the article, Maxime writes, "In comparison, Appwrite consistently performed better in maintaining this comfort zone, handling more virtual users, while keeping response time under these thresholds. These results highlight that Appwrite can support a significantly higher number of simultaneous requests, making it more scalable within these thresholds. Supabase, while still capable, reaches this comfort zone sooner, particularly when handling heavier loads." When comparing the results to the breakpoint test, Maxime also had this to say: "It becomes clear that Appwrite consistently handles larger loads more efficiently. In these tests, Appwrite demonstrated better scalability. In contrast, Supabase showed limitations under higher loads, particularly in the breakpoint test where it struggled to maintain stable performance beyond certain thresholds." Another interesting stat that was shared in this article was the idle consumption for both Supabase and Appwrite. This graph shows that Appwrite used 30% of the server's resources, while Supabase consumed a staggering 200%. To quote from the article again, "It was so unrealistic that I couldn't believe it at first, so I ran the test again, but the results were similar, confirming this is just how it works." Now, I have my own theories to why idle consumption was the way that it was, but I feel like that's better saved for another video after some more testing and research. So for now, that's it. I hope you learned a lot here, found it insightful, and leave me some feedback in the comment section. Let me know what you think, and until then, I'll see you all in the next video.